Hi everyone, this is Dr. Srikanth Yadav, Associate Professor, Department of IT. In the series of machine learning lecture, we will see the second video and the second content on the introduction to machine learning. Let's move to the syllabus. So here we will see what is meant by machine learning and what is the role of machine learning. So as per the eminent Professor Arthur Samuel, he pointed and he coined the definition of machine learning like a pioneer in the field of artificial intelligence and computer gaming coined the term machine learning as the field of study that gives computers the capability to learn without being explicitly programmed. That means not like a traditional programming environment machines, here the machine learning will make the machines to think and to take decisions based on the experience and the input what we are going to provide. Now, how it is different from traditional programming? In traditional programming, we feed the input program logic and run the program to get the output. That means in C programming, if you are trying to print arithmetic operations like addition of two numbers, we need to give the input and we will get the output. Whatever based on the input we are giving, we will get the output. Whereas in machine learning, we will feed the input and the output. That means the input value and some expected output will feed and will run the program on the machine during the training, and the machine will create its own logic which is being evaluated while testing. So in traditional programming, we are giving an input and we are getting an output. Whereas in machine learning, we are giving input as well as expected output. Based on the input and expected output, the machine will think and evaluate its own test case during the testing process. Look at the diagram here. In traditional programming, we are supplying data as an input and we are writing a program relevant to the data, relevant to the task, and we are getting an output. This is going to be happen in traditional programming. Whereas in machine learning, in addition to the data, we are providing the expected output or assumed output. The machine itself will think and will analyze and evaluate its own output in the form of a program during the test case. Now, what are the basic terminologies we will encounter during the machine learning environment? That means during the initial stage of machine learning practicing or machine learning program, we need to undergo some basic terminology. Among them, the common terminology is the model. Now, what is a model here? A model is a specific representation learned from data by applying some machine learning techniques or algorithms. A model is also called as a hypothesis. That means based on the input and based on by applying some known machine learning algorithms or popular machine learning algorithms on the input data, and we'll call the procedure as model. And the model what we are going to design or develop, it is based on the hypothesis. Coming to the feature. A feature is an individual measurable element or property of our data. A set of numeric features can be conveniently described by a feature vector. Feature vectors are fed as an input to the machine or the model. Example, in order to predict the fruit name or to assign a label for the fruit, we will encounter with some of the features like the color of the fruit, size, shape, hardness and smell. These are the specific parameters which are related to a fruit. Like that, every object or entity that we are going to predict using ML or machine learning will have its own set of features. A feature can be of any type. It can be a numeric type or it can be a character type, it can be descriptive or continuous type. The third terminology is the target, or we can also call it as a label. A target variable or the label is the value to be predicted by our model. Like we have passed some fruit images and the machine has to predict the correct name of the fruit. So that is called target. So for the fruit example discussed in the feature section, the label with each set of input would be the name of the fruit like apple, orange and banana. Based on the given input, the machine has to predict the exact label which is relevant to the image or data that we supplied. The fourth terminology is the training. That means in order to the machine should get to acquire the capabilities of self-learning and self-decision making, we need to provide a specific training to the machine. The idea is to give a set of inputs in the form of features and its expected output as labels. So after training, we will have a model, that is it is a hypothesis model that will then map new data to one of the categories trained on. So here what we are giving, we are supplying a set of inputs, we will call it as a features, and an expected output in the form of a label. So by providing these two, the machine will undergo the training for specific amount of time, then the model will learn, will get an experience based on the input what we provided based on the hypothesis environment, and it is trying to predict the output values based on the categories what we provided. And another terminology is the prediction. Once our model is ready and it can be fed a set of inputs to the which it will provide a predict output. That means we trained the model by supplying the input and a set of expected output or class labels or target labels. Now the machine is ready to handle with the new set of data. Based on the knowledge it was acquired, it is trying to predict the value. Based on the percentage of prediction or the accuracy of the model, either we can increase the training or we can change the training pattern. So these are the 5 commonly used basic terminologies in machine learning model. Now let's move to what are the different types of machine learning models that we'll encounter in our daily life or in real-time applications. So the machine learning models and the types broadly have been classified into 3 categories. They are supervisor learning, unsupervised learning, and semi-supervised learning. Let's have a small discussion on each and every category. Now in supervised learning, when the model is getting trained on a label data set, the label data set is one which have both input and output parameter. That means the known input is going to be mapped with the known output. We already know the input values and we already know what are the targeted variables. So based on the input, the known input is going to be mapped with the known output. Let's see the diagrammatic representation. See here, our input is known and output is also known for us. We are mapping the known input with the known output by applying the specific functions. That's called supervised learning. Let's have a small example here. In supervised learning, we are supplying some labeled data. Here you can see the different shapes of mathematical have been given, like triangle, rectangle, hexagon and circle. Now this is our input and every shape is having its own label, and that known data we are feeding into the machine. The machine will get the input based on the name of the shape, and we are applying some machine learning algorithm to train that to understand the input value, that we are calling it as a model, and we are testing. Once the model is ready with the acquired knowledge from the input, now we are testing some sample data, because already the machine knows the shape and its name. So here in test case we are giving 2 shapes, one is circle, one is triangle. Now the machine is trying to predict whether the symbol is triangle or circle. So in this case both have been predicted successfully. We cannot guarantee that in all cases it will do the correct predictions. So it may go wrong also. Based on that, we need to change the training pattern and testing pattern in supervised learning. Look at carefully here. In supervised learning, we are providing a known input set of data, that is called labeled data, and already we know what are the outputs we are going to get, and every output has been known in prior as a predicted label. So in supervised learning, what we are doing, a known input is going to be mapped with known output. Okay. Now look at the next one. In the second type of machine learning model, it is unsupervised learning model. In unsupervised learning model, machine neither classified nor labeled and allowing the algorithm to act on the information without guidance. Let's look at an example here. In unsupervised machine learning is more challenging than supervised learning due to the absence of labels. That means we are not going to provide the output labels or target labels. That means output is unknown for the machine. Only we are mapping the known input with unknown output. So here the machine doesn't know, or machine doesn't have any knowledge, it was not trained on the known labels. That means output is unpredictable. So based on the unpredictable output that it was generated, it has to assign one class label based on the knowledge it was acquired from the input. Now look at here. Here we are giving some unlabeled data. In the previous example, we have given label for each and every shape. In this example, without giving the label, we are supplying the data as an input. The machine doesn't have any information based on the shape, number of sizes, number of sides, and its representation of relevant data. It has been grouped. Look at here. Here 2 rectangles have been grouped, 2 circles have been grouped, and 2 triangles have been grouped. That means priorly it doesn't have any input, it doesn't know the label of the shape, but based on the appearance and the size and the shape, the machine has grouped them. Now we can assign, we means in the machine may assign a label based on the knowledge that we are providing during the training process. And the third category is the semi-supervised learning. In semi-supervised learning, the name itself indicates it is a combination of supervised learning or unsupervised learning. Let's see an example for this. Here in semi-supervised learning, the input is completely known for us. We are passing a set of records or data which is already known with the valid class labels, whereas the output, it is in the semi-nature. Some records which are predicted with the based on known class labels, some records may not be predicted because for some records the labels are missing or labels are not being provided. So it is a combination of both supervised and unsupervised model. Look at here. In unsupervised, here we are providing a set of input data with valid labels, and we are also giving some partial labeled data. Now we are supplying one unlabeled data here. Now based on the labeled input as well as unlabeled data or partial labeled data, the machine is going to predict and it is going to assign a label based on the input it has been received during the testing phase. So it predicted it as an apple. Okay. Let's move to the fourth category as reinforcement learning. In reinforcement learning, it is a branch of machine learning which focuses on how agents can learn to make decisions through the trial and error and to maximize the cumulative rewards. So in reinforcement learning, it allows machine to learn by interacting with an environment and receiving feedback based on their actions. That means whatever output it has been generated based on the feedback, the machine can train and it can adjust its knowledge and it can activity will be done. So in reinforcement learning, the environment is fed up with the agent. The agent is going to predict by applying the action, and once it was predicted properly, the agent is going to be rewarded. If it was not predicted properly, the feedback will be taken and retraining is going to be applied on the data. Now we will see some of the examples under supervised learning and other categories. In supervised learning, the commonly used machine learning pattern or technique is classification. So it is a supervised learning model where output is having defined labels, that is in the form of discrete value. Like we want to predict the species type, one bird or reptile information we are having, we are going to assign the class label, or biological sequencing or DNA RNA sequencing. Example, like a Gmail classifies a mail in more than one class like primary, social, promotions, spam or updates. The second category of supervised learning which commonly used is regression model. So it is also a supervised model where output is having continuous value, it deals with the numbers. Example, predicting the temperature, stock market or stock prices and house value predictions. Now we will see what are the various applications which are directly related to the machine learning in real-time applications. So when do we use machine learning? That means when human expertise does not exist. when human expertise does not exist, then we need to take the help from machine learning. Example, navigating on Mars. When we sent a satellite on the Mars to collect the data on the Mars, to analyze the rock and soil and dust on the Mars, here human expertise is not possible to reach there. So we are using the machine learning algorithm. With the help of machine learning models, we are sending some robots or elements on the Mars to test. And the second one is humans can't explain their expertise. Example, speech recognition. Like if any fake audio or video has been released and it has to be detected, it has to be analyzed properly whether the voice is a true or fake or not. It's a speech recognition. And models must be customized. Example, preferring or suggesting personalized medicine based on the patient condition. And then one more, models are based on huge amounts of data. Example, genomics or RNA DNA sequencing, where we will have data sizes in larger scale. Look at these are the examples, like predicting data or analyzing data on Mars, speech recognition, genomic sequencing, and suggesting personalized medicines. And we will see some more examples which are best solved by applying the machine learning model. Example, recognizing the pattern. The facial identities or facial expression recognitions. And one more is handwritten or spoken word recognitions and analyzing medical images. These are the complex areas or domains where human expertise is having a challenge in detecting or predicting. And generating patterns like image patterns and motion sequencing of the data. And some more examples, recognizing anomalies like detecting or predicting unusual credit card transactions, unusual patterns of sensor reading on a nuclear power plants, predictions, future stock price or currency exchange rates in coming days, that is future predictions. And the commonly used most real-time examples where machine learning is going to play a key role, one is a web search, computational biology, e-commerce, finance application, space exploration, robotics, social networks, and software debugging. These are the major domains where ML is playing a crucial role in current scenario. And thank you for this session.